All right, IM3 classes. Today we're going to be simplifying radical expressions. Actually, we're going to be working on rational exponents some more. Simplifying rational exponents, and then we're going to get into those radical expressions. So starting off, reminder, properties of exponents, working with the radical exponents here. The power property, so if you're multiplying with exponents, add the exponents together. If you're taking a power of a power, you multiply the exponents. And then the other one, the quotient, if you're dividing with exponents, dividing with powers, you subtract the exponents. Those are going to be the big ones. Then negative exponents, flip fractions, all right? Moving over here, so what we have is a bunch of simplifying. So this is a little bit easier than we did last time when you're dealing with just whole numbers and adding and subtracting, but now we're dealing with fractions. So if you notice, we all have the same base, P, B, B. We're going to worry about the fours in a minute. Since we're all multiplying here, we just need to add these. There's a negative exponent here. Deal with the negative. We'll deal with the negative if there's still negative at the end. But so with these, I just need to add those fractions. Negative 5/3 plus 2 plus 5/4. So remember to add fractions. I'm actually going to give a little bit more space in between these. So plus 2 plus 5/4. We need a common denominator between these. This one here, just a reminder, if it's not a fraction, make it a fraction by putting it over 1. So common denominator between 3, 1, and 4. That's going to be 12. All right, the LCD between those is going to be 12. So I need to change these denominators to be 12. So I need to multiply top and bottom of this one by 4, top and bottom of this one by 12, top and bottom of this one by 3. All right, and that's going to get 12s on the bottom. So 4 times 3 is 12. 4 times 3 is 12. 4 times 5 is 20. And then it's this negative plus 2 times 12 is 24 over 12 plus 5 times 3, that's 15. 4 times 3 is 12. Now, when I add these, it's all just going to be over 12. So negative 20 plus 24 is 4, plus 15 is 19. So 19 over 12. So these p's, negative 5/3 times plus 2 plus 5/4, that's going to be p to the 19/12. And then the one thing you need to do is just take care of this. You just multiply these together. 4 times 4 is 16. There we go. So this is just working with fractions, fun stuff. Multiplying fractions. So here, if you remember multiplying fractions, you just multiply straight across. Power of power, you multiply the powers, multiply straight across. 1 times 4 is 4. 4 times 3 is 12. And then reduce 4 over 3, or 4 over 12 reduces to 1 over 3. I guess the shortcut would have been to cancel out the 4s here and then multiply. You get 1 over 3. Oh, well. So this is just m to the 1/3. This one here, subtraction. So a couple things. Make sure you remember that there would be a 1 there. So I need to do 1 minus 3/4. This isn't a fraction, so I'm going to make it a fraction. Put it over 1. Common denominator between 1 and 4 is 4. So I just need to multiply top and bottom of this fraction by 4. So 1 times 4 is 4. So I get 4 over 4 minus 3 over 4. That is 1 over 4. All right, so it's going to be, then here, reduce this fraction, 4 over 2. So it's going to be 4 over 2 is 2. X, and then the exponents work out to 1/4. Oh, now, so I ever see a problem and you just look at it, you're like, nah, I don't want to do that. It's one of those problems. It's a lot of fractions, but whatever. moving on. So just look at the A's for right now. So it's going to be 1/2 plus 3/2. Oh, they already have a common denominator. Sweet. So you just need to add the numerator. 1 plus 3 is 4. Make sure you check to see if this reduces. 4/2 reduces to 2. All right, so it's going to be a to the second power. And then the b's have their own fractions. So 3/2 and 4/3. So I need to add those. So 3/2 plus 4/3. Got to multiply top and bottom of this one by 3, multiply top and bottom of this one by 2 to get the common denominator. Sorry, I skipped a step. Common denominator is 6 between 2 and 3. So 3 times 3 is 9, 3 times 2 is 6, plus 2 times 4 times 2 is 8. 3 times 2 is 6. So 9 plus 6 is 17, or 9 plus 8 is 17 over 6. So it's b to the 17 over 6. And then don't forget to multiply 3 times 2 is 6. All right. And last one of these. All right. So this exponent gets applied to each base in here. Oh, I guess there's 2 different ways to take care of this. Since they're both n, we can simplify in the middle and then do the power outside, or we can do the power outside and I'm going to do the power outside. So 3 times 2 is 6, and then n 5 has, so 5 over 4 times 2. Again, if it's not a fraction, make it a fraction, and then you just multiply straight across. 5 times 2 is 10, 4 times 1 is 4. So this is n to the 10 fourths. All right, so now I need to add those. So it's going to be and actually, you know what? We're going to make it easier. I just had a little brain fart there. Make it easier. This reduces to 5 over 2. All right, so it's going to be 5 over 2. There we go. So now I need to do 6 plus 5 over 2. 6 is not a fraction, so let's make it 1 by putting it over 1. Multiply top and bottom of this one by 2. That 2 is ugly. There we go. So I get 2 times 6 is 12. 2 times 1 is 2, plus 5 over 2. That comes out to 17 over 2. So this all simplifies to 17/2. N to the 17/2. Lots of fractions. All right, moving on. So this is just like the buddy system we've been doing in the warm-up. And what we're going to do is, so we have 2 different radicals here. We're going to simplify it. Do a buddy factor tree on each number. So 8 expands into 2, or is 2 times 4, and then 4 is 2 times 2. I'm going to do 1 for 10. So 10 is 2 times 5, and that's it. So I'm going to put everything all underneath one radical. So I can just combine the radicals into one and put all our numbers, and I'm going to expand the variables in there. So I have 1, 2, 3, 4 2s. So 1, 2, 3, 4 2s, 1, 5. And then b cubed. So I'm going to have 1, 2, 3 b's, another b cubed. So let me highlight some things just so we can see where everything's coming from. So the 3 2s put in here. And then the 2 times 5, that's going to be here. B cubed expands to b cubed here. And then the last one, b cubed expands to b cubed here. All right, so that's where everything is coming from, all underneath the radical. Put it in order so the numbers and letters are next to each other. It makes it easier to find pairs. So let me, so we're not confused, let me get rid of the highlighting. There we go. So now you just look for pairs, and for every pair, put 1 on the outside. So I have a pair of 2s. So 1 2 is going to go out on the outside, cross it out. I have another pair of 2s. So 1 2 on the outside, cross it out. And then I'm going to have a lot of b's. So pair of b's, 1 on the outside, cross it out. pair of B's, 1 on the outside, cross it out. And then one last pair of B's, 1 on the outside, cross it out. Multiply everything left over. So B times B times B is B cubed. 2 times 2 is 4. So that's going to be 4B cubed with 5 on the inside. All right. Let's look at another one. So here, difference in this one is I have a cubed root now. So I'm going to do a factor tree. It's going to be 3 times 5. This is going to be 3 times 3. I'm going to put it all underneath one radical. 3, so 3 times 5 and 3 times 3. So I have 3 3s, 1, 2, 3 times 5. Just put them all so they'll make it easier to find. And then x squared is going to be x times x. X to the 4th is 1, 2, 3, 4. So this time, because I'm not doing a square root, I'm doing a cubed root. So instead of pairs, I need to look for groups of 3. The root tells us how many sets I need to pull out. So for every group of 3, so I have a group of 3 3s. For every group of 3, I put 1 on the outside, cross it out. Then I have 3 x's here, 1 on the outside, cross it out, and then another 3 x's. So looking for groups of 3s. So I get 3x squared, and then the square root, and 5 is left over. All right. Look at a bigger one, pay attention to the root. So it's the 4th root now. I'm going to separate this out. So 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. Then I have 2 times 2 here. And put it all underneath one big radical. So at the bottom of the trees, I have 1, 2, 3, 4, 5, 6, 7 twos. 1, 2, 3, 4, 5, 6, 7, and then 1 times p, and then expand the p cubed. Right? There's a 4, so I have to look for groups of 4. So 1, 2, 3, 4 twos. Group of 4, 1, 2 on the outside. 1, 2, 3 twos, not enough. 1, 2, 3 p's, not enough. So all I have is a 2 on the outside. And then it's the 4th root of 2 times 2 is 4 times 2 is 8. P times p times p is p cubed. All right, so just like that buddy system, and we are pulling out groups of 4. All right. I think we're gonna skip that one. We're gonna move on to the last topic for today is rationalizing the denominator. What this means, it's improper to have an irrational number in the denominator. So irrational numbers are numbers that can't be expressed as a fraction. So those are things that have decimals that never end. So pi would be an irrational number, and then square roots of non-perfect squares, those are very common irrational numbers. We don't want them in the denominator because it's hard to divide with that. So what we're going to do to rationalize the denominator, all you need to do is multiply top and bottom of the fraction by the denominator, the irrational number in the denominator, or the square root here. So how this all works, and we'll simplify it. So square root of 2 times square root of 5, you can put that all underneath one square root. Square root of 2 times square root of 5. Right? This is square root of 5 times square root of 5. So it's square root of 5 times 5. So you can put those all underneath one. All right. From here, multiply it out. Square root of, so 2 times 5 is 10. 5 times 5 is 25. And then the square root of 25 is 5. Right? So what I want to point out here, a square root times itself is just equal to whatever numbers in that square root. Right? So square root of 5 times square root of 5 is 5. Square root of 8 times square root of 8 is 8. Square root of 13 times square root of 13 is 13. So you multiply and it's the same number. All right. The most common mistake that I'm going to see is that kids are going to want to simplify this and do it as square root of 2. This 10 is protected by that root. It does not simplify with the 5 on the bottom. Can't simplify it. If they're both under it, we could work with that. But here, this is protected by a root. This 5 is not allowed inside to simplify it. So that is as simplified as that gets. Look at another example here. So we want to multiply top and bottom by the square root of 10. All right. So square root of 10 times square root of 10 is 10. Square root of 8 times square root of 10. So here's the thing. 10 times 8 is 80. We can simplify this even further, and we need to take that step. So I'm going to do a factor tree on 80. So square root of 80, I factor it, that's 2 times 40. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. So if I were to simplify that, so that's 1, 2, 3, 4, 5. I have 5. Looking for pairs, it's just a square root. So pair of 2s, 1 on the outside. Pair of 2s, 1 on the outside. And so there's 2 times 2 is 4, 5 left on the inside. So square root of 80 is 4, square root of 5. So here's what does simplify. Now this 4 is not protected by the radical. I can reduce this fraction here. 4 over 10 reduces to 2 over 5. This 5 is protected by the square root, so it doesn't simplify this one that's outside of it. So that is as simplified as it gets. All right, let's do one more. Square root of 15 and 3. So I'm going to multiply top and bottom by square root of 15. Square root of 15 times square root of 15 is just 15. Square root of 3 and 15 is 45. I can simplify that, so I'm going to do a buddy system. So 45 is 3 times 15. I probably should just left it as 15. Anyway, 15 is 3 times 5. So to simplify that, I get 3 times 3 times 5. 3 times 5, that looks better. Pair of 3s, 1 on the outside. So this is 3 root 5 over 15. And then the last step, I can reduce that. 3 over 15 is 1 over 5. So it's 1 root 5, or just 5 over 5. Again, this 5 is protected by a root, so it doesn't simplify with this one down here. This is as simplified as it gets. And that is it for today. Yeah, that'll do it. We'll see you guys next time.